I'm Ethan Kwan, and today I'm going to be showing you trends on the periodic table. Okay, so I have a periodic table here, and I want to see if there's any trend or relation between where the atom in the periodic table is and where the size of the atom. Okay, so you might think that it's really easy to figure out what the size of an atom is because, well, you might imagine an atom like this. Let's just take, I don't know, magnesium here. So magnesium has 12 protons in the center. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. No, wait, no, not 18, 12. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we have 12 atoms in the nucleus, and then you might imagine 12, well, some people imagine 12 electrons going around in these orbits. Now, of course, this is not correct. This is totally wrong. This is one of the most wrong things in this. No, this is a great way to start off chemistry, but it is super wrong. What it actually is, it's what's called a cloud of probable electron locations. So if these are the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, oh, too far apart. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 12, sorry. Okay. And you might imagine okay, so this is what you might imagine, right? That is completely wrong. What it actually is, it's what's called a cloud of probable electron location. So there's a high probability, 90% or more, of the electron being in this area. But then there might be some probability that the electron is here, though not as much as the inside there. Right? And not much probability that it is right here. But there's still some probability. And of course, there is also some probability that it's going to be in here. So this is basically what an atom looks like. It looks like a star. Okay, so this is what an atom looks like. So it could be anywhere in here. It could be maybe here, let's say. If that atom's there, what's the radius of the atom? Well, it's pretty easy to figure out. It's just this length here, right? That's the radius. But then you might look at it at another moment and say, well, now the atom's over here. So what's the radius now? Well, it's this. It's this length here, radius. So the radius can change. So how do we figure out the exact radius? Well, we need two atoms in a bond, or not even we don't even need a bond. We just need to figure out what okay, so let's say there's an atom here. I'm not really naming the atom. And then if it's cloud of probable electron location, right? And I'm not drawing actually, you know what? I am just going to copy this. Okay, so I'm just going to take this here, copy it, paste it. No. Move it up. Take out this, take out that, take out that, take out that, that, and that. And now here's an atom. Okay. And now I'm going to copy this. And then put it right here. So this is how close an atom can get without bonding to each other. Okay, so then what you can do is take the distances between the two radii from here to here. But this is not the radius, this is two radius. So you have to take the middle of that, and that is the radius. This is the radius, and that is the radius. This is 2r. So that we can figure out is the outermost, how far it can get. So that is how to figure out the radius. Okay, so without further ado, let's look at the trends on the periodic table. So we know hydrogen is tiny, and we know oganesson here, or oganesson is big. This is kind of an old version of the periodic table, so this is not entirely right, but oh well. Okay, so let's look at a random atom. Let's look at potassium here. That's kind of blending in. That blends in too well. Maybe, okay. Let's look at potassium here. So what happens when you go from here, from the left side, all the way to the right side? Does it get bigger, smaller, stay the same? Try and figure it out. Well, okay, so let's look at potassium here. So potassium has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 protons, and change colors here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and there's one really far away called 19. And then there is going to be some charge that's pulling in, right? So this has a positive 19. But let's look at Krypton over here. Krypton has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. 36 protons, so it has a positive charge of 36, and it has much more, it has also a bunch of electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So the outermost electrons will be pulled in more because there's a bigger charge here. So that means the radius here, and the way I drew it, it looks like it got bigger, but it's actually smaller because the electrostatic force or the electromagnetic force pulls in more. So that's why the radius is smaller. So that means that if you go from row to row, row to row, you get you get smaller. Smaller. Okay. So what happens when you go down a period? What happens if we go down? Well, okay, so let's look at hydrogen here. Hydrogen looks like this. Ooh. It's one electron. It's kind of lonely. Okay, so it's pretty big actually, and I'm using the Bohr model. Sorry. Okay, that's totally wrong. Okay, so that is hydrogen, and let's look at francium. Francium, and I'm sorry, but I'm gonna draw this. I'm gonna probably speed this up. It has 87. 1, 2, 3, 4. 85, 86, 87. Okay, got it. Okay, so here's the nucleus of francium, and here the outermost electron. So looks like this got bigger, right? Because there are more here, and the outermost electron can go farther away because there's a new shell of orbitals, because all the other ones were in here. Now there's one here, and it's farther out, so it gets bigger. So the radius, if you go down, gets bigger. So what's the smallest atom? Well, if you go up here, you get smaller. Right? Okay, so if you get smaller up and smaller to the left, what's the smallest atom? Well, it's going to be something up here, the farthest up there, which is helium, which is true. It's the smallest atom. Okay, so what's the biggest atom? Well, it's probably going to be one of these guys. It's probably going to be radium or francium, these guys. Probably francium. Francium is probably the biggest atom of them all. Okay, so thank you for watching. I hope you liked this video. If you did, please remember to subscribe, like this video, and share this channel with others. If you didn't like it, hit the thumbs down button. Yeah, I would not suggest doing that, but if you really didn't like it, totally, you're free to do whatever you want. Go free. Okay, so otherwise, thank you for watching. See you at howtodoethem.com, and see you next time. Bye. Bye. Okay, bye. And that's it? Okay, bye.